Okay. So here's our steps and here's our assignment. So I'm gonna do a couple of practice questions. These practice questions are not on your assignment, so I'm not doing your questions for you. So these two little practice questions are the ones that I'm gonna do. But then if you go down, the rest of this is your assignment there. So the objective of this particular activity is to utilize your understanding of Avogadro's law. So this says that the volume of any gas is directly proportional to the number of moles of the gas. So this is a familiar definition. So 1 mole of any gas will occupy 22.41 liters of volume at standard temperature and pressure. So again, standard temperature and pressure is 0 degrees Celsius or 273.15 Kelvin. And then the standard pressure is 1 atmosphere of pressure. So this was discussed in the first semester. So we're going to utilize Avogadro's law there to solve application questions requiring the determination of the mass of a gas, the identity of an unknown gas by determining its molar mass, and the definition of or the determination of the volume a specific mass of gas will occupy at standard temperature and pressure. So for this activity, I'm introducing my boxes. So this is what I came up with to help myself once I had to start doing more difficult questions that involved this. So I started putting together these boxes. So these boxes will get more complicated, but this is a good way to introduce it because at this point we have only 3 boxes. Eventually, we'll get to a point where we can have 8 to 10 boxes here, but it doesn't matter. So how I ended up using these boxes was the same. So it didn't all I had to do was take a little bit of extra time to remember some extra boxes once I started building onto my little diagram here. So I used the boxes when I was first learning this to determine how many fraction bars I'll need for a specific equation. So my biggest issue was knowing exactly how many conversion factors I actually needed. So if I needed more than one, I couldn't figure out how many I actually was supposed to need because I wasn't at a point where I could actually think through the questions on my own. So this is why I came up with these boxes. So what I do is locate the box that contains my beginning units and then the one that contains my ending units. I then follow the path from the beginning box to the ending box, counting the number of boxes I touch on my journey. So what I realized is that the number of boxes I touched was equal to the number of fraction bars I needed. So as a big bonus, I then realized that the name of the box, so the units that were in the box. So look, you see here, one of my boxes is called mass of A. Another box is moles of A, and another one is volume of A. So what I realized also, and this came after, is that the units in the box were the actual units that I placed in the numerator of the corresponding fraction bar. So this box ended up inadvertently helping me in 2 different ways. So 2 issues that I was having: one, how many fraction bars I needed, and two, exactly what I put into the fraction bars. Because like I said, at this point, my note to myself didn't quite work the way that I had anticipated or that I had designed it to work originally. So once you add more fraction bars, it just doesn't you can't follow the same steps in the same way. So that's what I'm going to be using here. So I'm going to combine the steps that I did have. So a lot of these steps did actually still work, but they didn't work entirely. So I'm going to combine these steps with my little boxes now. So let's look at this first question. So I'm going to solve this one. Let me see. It's annoying. All right. So question simply says, how many moles of argon gas are there in 1.57 liters of argon gas? So if you have 1.57 liters of this gas, how many moles is that going to be? All right. So I'm going to go ahead and follow my steps. So the first few steps, like I was telling you before, actually do work. So my first step on any type of thing here is I got to recognize what kind of question is being asked. So in this question here, I see the phrase "how many." So that tells me that this is a special kind of math question. So I need to realize that what I'm doing here is a conversion process. Okay, so that means I'm going to go over to these steps here. And let's see if I can't shrink this a bit. So my step number one oops, this thing can't see. Sorry, I'm gonna have to get this. Okay. Enlarge this a bit. All right, we can still see everything. So I'm going to go to my steps here. So step one, when I realized that this is the conversion question, is always the same. So we start with the word convert. So I'm going to step two, step one. So I rewrite the question. So I put down my 3 parentheses. So I've got convert goes in the first one. And then my second one, I always take whatever I know, and I put that in. So here I'm given 1.57 liters of argon gas. And then what I want to do is turn this into, I don't want liters, I want to know how many moles. So I got question mark moles of argon gas I need. All right. So there's step one. Step two, I can now start putting my fraction bars down. So I see the word convert here. So that means that I'm going to be using my fraction bars. So I'm going to go ahead and add these in. And this still works just fine. So put these in here. All right. So this is going to be one time when having to actually use this computer for my math is going to be somewhat helpful. So I'm just going to come in here and put fraction bars down. So my fraction bar times my fraction bar, and then equals. So there's step number 2. So next part on my note that I go to is this. And again, it doesn't matter what the question is I found. It's always the same. Whatever this is always goes in this first numerator. So I'm taking 1.57 liters of argon. So there we go, I use that. So now I go on to step 3. So the next part of my note, again, what I found is it's always the same. So this next part of the note always goes to the back of my equation. So I want to know what I'm looking for. So I'm looking for moles of argon there. So now I'm out of my note. So what I'm going to do is I'm just going to go ahead and approach this like I normally would. So next thing I do is I'd come down and step 5, I'd put a 1 in the denominator there, so I can do that. So the next thing I do is I take this and I flip it here. So this must come from here. Whatever unit of measurement you end in, always has to come from this last numerator by the equal sign. So I'm going to go ahead and flip this in here. So there's step 6. Step 7, I'm now going to flip. I need to cancel. So again, this whole process is for the purpose of canceling out units. So I need to cancel this out. So I'm going to go ahead and move it down here. So in order to cancel it, I need to divide by it. So there's step 7. Now I'm on to step 8. This is where it kind of deviates a bit. At this point, you have to ask yourself, so it does require some thinking. So you have to ask yourself, do you know a set defined relationship here? Is there a conversion factor that you know between moles and liters? If I put a 1 down here, if I say you have 1 liter of gas, do you know how many moles there are in 1 liter of gas? Or if you say I have 1 mole of gas, do you know how many liters of gas there are? So in this case, you do. And that's Avogadro's law. So up here, we have that definition. So right here is your equivalency. This is your conversion factor for these 2 units. At standard temperature and pressure, 1 mole of any gas will occupy 22.41 liters. So in this question, we actually do have a conversion between these 2 units. So I can just fill this in. So I just put the numbers that define this equivalency next to my units of measurement. So the definition tells me I have 1 mole, and it tells me my liter measurement is 22.41. So I fill that in there. Now I'm able to cancel out these units. So I can cancel that part out. And now I just multiply across. So I go to the calculator and get rid of this. I just do 1.57 times 1 at the top. Put another fraction bar in there. So we'll do this legitimately here. So 1.57 times 1 mole of argon at the top gives me 1.57, and then my unit of measurement is moles of argon. And then on the bottom, I multiply 1 times 22.41, and I canceled out the units, so there's no unit down here. So that'll just be 22.41. So there's that. So then we'll just go on and we're going to equal this out. So now you just go into the calculator and you divide. So we do 1.57 divided by 22.41. And we get 0. So the calculator says 0.07005801 moles of argon. So again, that's not actually our answer. So the last thing we need to do, and according to our California standards, is we need to know how many digits to actually put in this answer. So we look at our original measurements. So in this case, we have only a single original measurement. This is not a measurement. So we didn't actually measure this 22.41. This is a definition. So really, I wouldn't even use this. So technically speaking, anytime you put in any type of constant to a math equation, so this is a constant, it's a constant that defines this relationship, or the measurement pi, for example, if you're ever calculating the radius of a circle and need the measurement pi, you know the number of digits for pi just goes on almost infinitely. So you need to know how many digits to write down. There's actually a rule for this as well. Now, this you don't have to know at this point, but there is a rule. So the number of digits that you write down for a constant is equal to the fewest number of measurements you have. So I have 3 digits in my measurement. So really what number I would write here, I would only have 2 digits in this particular equivalency. So really I would write down 22.4, and I wouldn't put the 1 down there because I don't have enough digits in my original measurement. Again, it's not a big deal at this point, but in college it is. Oh, it's something I always wondered is how do I know how many digits of pi to write down? And that's how. So I look at my original measurement here, and I only have a single one. So it has 3 digits. That means my answer needs 3 digits. So if you remember, the rules say that leading zeros do not count as significant. So these aren't actually significant digits. My first significant digit isn't until I get to the 7. So there's 1, 2, 3. So this 0 is going to be where I cut off my answer. So I look at the back and I see a 5. So that means this 0 gets rounded up. So my correct answer for this would be 701 moles of argon. So there we go. So if I had 1.57 liters of argon gas, the actual number of moles of gas that would be in that balloon or whatever the gas is in would be 0.0701 moles. All right, so there's one. So let's take a look down here. Now, there I did it just using my step. Actually, let me go on before that. But I'm going to go ahead and delete this. So let's try it now instead using my little table up here. So I go ahead and I still do step 1, right? So step 1 says to rewrite my sentence there. So I rewrite my sentence. Next thing I would do is start to put fraction bars down. But like I said, as they become more difficult, you may end up having to start adding more conversion factors. So instead of 2 fraction bars, you might need 3 or 4 or 5 or 6. Okay, so I needed to figure out a way to try and come up with or try to figure out how many of those I actually needed. So this is where my tables started coming into play. So like I said up here, what I did with this little diagram is I used it to pick where I'm beginning and where I'm ending. So I look at my note. So again, this is another great part of this note. So here, my beginning unit of measurement is liters. So I look at my diagram. So there's my beginning unit of measurement is going to be in liters there. And then I look at my ending one. So it's in moles. So there's my ending box. So I need to go from this box to this box. So that's only one. So here you can see I have a direct line going from this box to this box. So what that means to me is I'm touching, in order to go from my beginning measurement to my ending measurement, I'm touching two boxes. That means I'm going to need two fraction bars for this equation. So what that would then tell me is okay, I'm going to come down here and I'm going to put my fraction bars in. So according to my diagram here, I needed two fraction bars. So I'm just going to go ahead and put these fraction bars in. So diagram says I need two, so I'll put two in. Then what I'll do is I'll move on to step 2. So I'll say, okay, now I can start to work this question. So then what convert now tells me is diagram. So look at your diagram and figure out how many fraction bars I'm going to go ahead and need. So then I can go in and start filling this out. So then I would do step 2. So that I'd put in 1.57 liters of argon. And then, so that gets rid of that part. So then I cancel that out. And then I do step number 3, or step 4. I drop down this. So I'm going to go ahead and drop this into my equation at the end. So everything else at this point is now the same. Oops, moles of argon. Okay, and then I do step number 5. I put a 1 down. So you can see now at this point, I would go back to my steps. Now I would do step 6. So I'd take what's at the end and flip it in here. So and then put that in there, moles of argon. And then step 7 means I have to cancel this out. So let me cancel that out. And that you always cancel out a unit by dividing by that unit. So then I move moles, then I move it down here. So now I can cancel it out. So now again, I would ask myself, okay, do I have a relationship between moles and liters? And we do. So 1 always goes next to mole. And if I have 1 mole of gas, it means that I have my 22.4 liters of gas. So then I'd go ahead and solve that. So the only real difference that I found once I started doing these more complicated questions is what I thought about when I looked at the word convert had to change. So instead of seeing convert and saying, oh, 2 fraction bars, I had to now think, oh, convert. I have to convert. That means I need to know how many fraction bars to use. So I have to look at the diagram. So it just became look at the diagram. So that's what we're going to look at now. So let's take a look at this question here. And we'll try this other way of thinking about it. So instead of saying, oh, convert 2 fraction bars, we're going to say, oh, convert. That means I need to know how many fraction bars to use. So here it says, how many liters will 45.0 grams of krypton gas occupy? So again, I see the phrase how many here. So that means I'm going to convert. It means I got the special type of question. So I'm going to go ahead and rephrase my question. So word convert always tells me to rephrase the question using my parentheses. So I'm going to go ahead and put these down. So I write convert, and then my second parentheses, I just take what I've been given. So 45.0 grams of krypton goes in there. And that's not what I want. I need to get rid of that. So my third parenthesis is always what I want. So I need some number of liters of krypton. So I'll put that down. So again, now I'm looking at convert. So the convert now tells me in my mind, oh, how many fraction bars? So I find my beginning measurement and I find my ending measurement. So in this case, I'm beginning with a mass number. So I'm beginning in this box here. And I want to end, according to my note, in liters. So now I'm over in this box. So I'm going from this box to this box. So here you can see there is no direct connection between the two. And this is because every single gas has a different mass. So the volume of one gas is not going to have the same mass as the volume of a second gas. That's because every single gas has it made up of different atoms or different combinations of atoms. So every single gas is going to have a different mass. So in order to go from mass to volume, I first have to go through my common measurement, which is moles. So remember, the base definition of moles says that 1 mole is equal to 6.02 times 10 to the 23 individual molecules. what you have a mole of doesn't matter. So if I can figure out how many moles of gas I have, then I can compare, then I can move on to this. So then my definition now will be true. So 1 mole of any gas. It doesn't say 1 gram of any gas will occupy 22.4 liters. And that's because 1 gram of every gas is a different quantity. So in order to get from here to here, I first have to touch my mole box, and then I have to go here. So now you see, according to my diagram, I'm touching 3 different boxes. What that tells me is for this question, I'm actually going to need 3 different fraction bars. So I'm going to have to come in here and add 3 fraction bars down. So this is where it gets more complicated for me. When you do enough of these, eventually you're able to think through them on your own. But in the beginning, this was a big help to me, just knowing how many fraction bars I needed. So I'm going to go ahead and put these in here. So let me see. Okay. In this case, I'm going to need 3 fraction bars. And now I can do an equal sign. So I'm going to go in here now. So this is my new step number 2. So instead of just automatically putting 2 fraction bars down, the word convert now tells me I need to know how many fraction bars I'm actually going to use. So I'm going to put 3 in. Now though, I can continue on with my steps. Now I'm fine continuing on here. So I can go on to step number 3, where I can start plugging stuff in. So I still get to use my note. So this is my second fraction, or my second parentheses, always goes in the top of my first fraction bar. So what I realized, it doesn't make any difference how many fraction bars you have. This now still always works. So that will always pop into the top of that first one. And whatever you end in, whatever is at the end of my note there, still will always pop into the bottom. So I need liters of this. Oops. Okay. So then I can keep going on. So that was step 4. Step number 5, I'm going to put a 1 under there. Step number 6, I'm now going to flip this into my last one. So now you see here, I'm going to have to flip this not into this one, but it still flips into the last one. So it will flip back there. Step 7, I have to cancel this out. It always gets flipped down to the denominator of the next one. You can see the steps are still working. It's just now I have a bit of an issue. My units are no longer lined up. So I have 2 boxes now that I need to figure out what to do with. This is where this second part of my diagram ended up helping me. So this is where I found that this is a bonus. So as a big bonus, I then realized that the name of the box, the units in the box, were the units that I placed in the numerator. So here I'm missing, I don't know what goes into this spot. I don't know what I didn't know what I was converting grams into. If I couldn't convert it directly into liters, I didn't know what I was supposed to put here. But I realized that all I have to do is go back to my diagram. So this fraction bar here corresponds with mass. So you can see the unit here is grams. So this is a mass box. The only place I can go with mass, the next place on my journey is over to the moles box. So that means this is the moles conversion factor. So what that means is this is the unit that goes in this spot right here. So this is going to be moles of krypton. Now, what this allowed me to do, now you'll see the next box from moles, I can go over to volume or to liters box. And you see that's what happens here. I end up in this box. I end up in liters. So each of the conversion factors relates to the box that you're in as you're moving along your journey. So I found out really quickly that, oh, this is actually quite easy. This diagram helps me twice. It tells me the number of fraction bars I need. It also tells me what to put at the top of each one. So remember, this is not the unit. I have one spot left here. I need to fill this in. This is where you have to remember that this is actually not the unit we want. We don't want to end in moles. So that means this unit must be canceled out. So if you remember anything, how do you always cancel something in math? You do the opposite of what it wants. So it's asking you to multiply here. So in order to cancel that, we have to move this down here. And then boom, I ended up with everything filled in. So that's where this diagram really helped me. You still have to think through the question. So it still requires a lot of thinking. So there's a lot to remember here. There was a lot of steps to remember, and you got to remember what you're doing within the equation. You got to remember the whole purpose of this is to cancel out units you don't want. You have to remember that to cancel something, you have to do the opposite of want. So as you're putting these units down, you have to remember why they're going in the spots they're going in. So this unit here, you had to, in order to get what went into this spot, you had to remember that the purpose of this denominator in this process is to cancel out what came before it. So in order to know what goes here, you always look up to the numerator that came before it. So now we can cancel. So notice though we have no numbers in. So now that you have, this is where you now remember what the conversion factors are. So this one should look familiar. So we're comparing moles and grams. This is what you just did on Tuesday. This is your mole and your gram conversion. So this is where we come down here. So notice here in my steps, you have your mole and you have your gram. This is your gram and mole conversion factor. So you just follow the steps. We always put a 1 next to mole. If I see mole in one of these equations, we put a 1 next to it. So there it is. Now I'm missing a gram number. So you have to ask yourself, where do you always get a gram number from in this class? And the answer is always to the periodic table. So in order to know what this is, I'm going to have to go over to the periodic table. So let's actually go here and open this up. I have a periodic table open. So let's take a look at this periodic table here. And can I see this? There we go. So there's krypton. So krypton's element number 36. So we look at the mass and we see it's 83.798. So again, you can put 83.798 down, but I'm not going to. I'm going to do it the correct way. So I'm going to look at the measurements I have. The measurement I have here, and it's the only one. This has 3 digits. So the constant that I'm going to write down here is 3 digits. So I'm going to look at this 7. It has a 9 behind it. So I'm going to round up to 83.8. Again, not a big deal, but technically that's the way it's done. So there we go. Now I fill this conversion factor in. That means I can go ahead and cancel out these units. So I'll cancel this out, cancel this out. So there goes my grams of krypton unit. It's gone. Now I come over here, and once again, I just have to compare what the units are. So here I see liters and moles. So once again, this is where we have this definition, where 1 mole of any gas occupies 22.41 liters. So again, I see the unit mole. So remember, anytime you see mole, we're going to put a 1 next to it. So 1 mole, 22.4 liters of volume. So there we've now filled that in. So since that's filled in, we can go ahead and cancel this out. So I'll get rid of moles of krypton. There we go. So now you have everything filled in. So we're just going to do what we did before, and we're going to multiply across. So we're just going to multiply everything across and put a fraction bar in there and do it correctly. So we're not going to short steps here. So 45 times 1 times 22.4 liters of krypton. So let's plug that into the calculator. So 45 times 1 times 22.4. So at the top, we have 1,008 liters of krypton. And then on the bottom, we have 1 times 83.8 times 1. So 83.8. And then we'll just punch that in. And we get 12.0286396 liters of krypton. So again, this is not the answer we're going to write down. So again, we go back to the original digits. We have 3 digits. That means we need 3 in the answer. There's my 3rd digit. So this is the one that gets rounded. So I look behind it, I see a 2. So it's going to stay 12.0 liters of krypton. So there's the answer to that question. So you can see here it's a more difficult question. But if you use my diagram and you still use my steps here, you can start to think through this question. It does take some time. So again, we don't want to freak out about this kind of stuff. It takes time. There's just no way else around it. So it does take time. But as you become more and more familiar with doing this process, you get to the point where you can just think through these questions. You've seen them so many times that you just know that if I see a gram number here, I'm converting it into moles. And you'll have this diagram in your head. So you'll just see it and you'll say, oh, I need to go here from here to here to here. But this diagram does make a big difference when you first start doing it. So it's a big help. And again, knowing how many fraction bars you need, and then also telling you what units go at the top of each of the fraction bars. And then when you know the units that are in the numerator, you'll also be able to then know what units are going to be in the following denominator. All right, so like I said, I wanted to do a couple questions there so that you are able to see. So you're able to get some practice time with this.